Hello everyone, let's solve this problem. Count the number of distinct integers after reverse operations. You are given an array numbers consisting of positive integers. You have to take each integer in the array, reverse its digits, and add it to the end of the array. You should apply this operation to the original integers in nums. Return the number of distinct integers in the final array. So let's take the first example. We have the nums array. Then how many of these numbers are distinct, right? We have for first example, how many numbers we have? We have five numbers, right? How many of them are five? How many of them are unique? As you can see, all of them are different, right? So we have five numbers different, right? Then what we're going to do is we're going to reverse the digits of the numbers that are already that are greater than 9, right? So because the numbers that are less than that are less than 9, that are less than 10 are when we reverse their digits, they will be the same. So we are not going to they're they are not add a value for distinct integers, right? So we are not going to reverse their digits for numbers that are less than 10, right? So first, what we're going to do is we are going to make this a set, okay? So we need to in order to know the number of distinct numbers. Saying what we're going to do is we are going to reverse the numbers that are greater than 9 and check whether they are not here or not, whether they are in this set or not. So for this example, for example, for this one, what we're going to do is first we have a set of numbers, right? We have this set of numbers 1 and 3, 13. I mean 10 and 12, and 12 and 31, right? We're gonna have 12 and 31, right? Then what we're going to do is we first we iterate over for each number. First, our initial count is five, right? Our unique numbers are five, and we iterate over this array. And if the number is greater than 9, we are going to reverse the digits, right? Since one is not greater than 9, we are not going to reverse its digits, right? Then we are going to see 13, right? 13, when you reverse it, it's gonna be 31, right? 13 is gonna be 31. Then if 31 is in this array, right? So the number of distinct numbers is not going to change. And 10 is gonna be 1, right? When we reverse it, it's gonna be 1. So it's gonna be 1. So yeah, it's gonna be 1, and then and one is not yeah, one is here, right? So the number of distinct integers is not going to change. But for this one, 12 it's gonna be 21, right? But we don't have any 21 here, right? So the number of distinct integers is gonna be plus 1, right? It's gonna be 6. And when we see third one, it's gonna be 13, right? When you reverse it, and the number of distinct integers is 13. 13 is here, where it's not going to change. So the time complexity for this way is of n square of n, and the space is also of n, right? So we are going to solve this problem, and I'm going to solve this problem in of n space complexity and the time complexity, right? So let's go to the implementation. So first, let's say distinct, right? Or let's say distinct. The distinct is just a set of these numbers, right? And a set of numbers. And what I'm going to do is, let's say I have a function which reverses the digits, right? So reverse digits, and we're gonna give it a number. Then what we're going to do is, while this number is greater than zero, what we're going to do is, let's say we have ans, right? We have an array, and what we're going to do is, first, we are trying to remainder, right? Let's say r is any modulo, or let's say that let me append ans to append n num modulo by 10, right? And once we are done this, then I'm going to then num is integer division by 10, right? Then whenever we are done, we are going to first, since this has to be a string, and it's gonna be string, then the join is often, I think, yeah, join is return int of, yeah, join is often, it takes often operation to create a string, saying else that's gonna be, yeah, doing this answer to in a string and return this one is gonna be, but do I need to use int? For example, if it's 10, the remainder is gonna be zero, right? So, but since one is, yeah, it's gonna be zero one, but we need one, right? Because when reverse is gonna be one zero, zero one, but we need to know that's one. So for num in nums, then if num is greater than 9, what we're going to do is we reverse it, right? So we are going to call this function for num and see reverse a digit or new num. We can say new, I can say new num, right? Let's say new num is going to be this one. What I'm going to check is if new num is reversed when new num, if new, one thing I can do is just yeah, adding to a set. If it, I can just add it to set, right? Doesn't matter. Add it to new num instead of checking, but I can check whether it's there or not. So return length of distance, right? So we need to return this length. So the time complexity is gonna be open and space is gonna be open, right? I assume like this one takes open, and the rest of them are open of one operations. So, and this one takes for each number. This takes log. Oh yeah, this takes log of. So the time complexity is not going to be since it takes, for example, the largest number is gonna be 10 to the power of 6, right? So it takes of log, takes log 10 to the power of 6 is gonna be base 10. So 10 to the power of 6, how many digits it's gonna have? It's gonna have six digits, but it takes log of n. Let's say n is the length of the digits, right? So it takes log base 10, and for each operation, let's say we have done this thing. So in one optimization, if okay, if the reverse is gonna be if num is not going to, if new num is not in distinct, okay, you can say distinct. If it's not there, we are going to add it. So instead of adding each time without unnecessarily. So for the time complexity for this one is n login, right? Because n login is gonna pass. Yeah, it's gonna pass because this one is too small, right? As like it's gonna be n times log, let's say k, because k is gonna be the length of the largest digit, right? The largest digit is gonna be 10 to the power of 6. So it's not O of n operation, but it's still O of n times log, let's say k, base 10, right? So it's gonna be time complexity complexity is gonna be of n log, let's say k, base 10, right? But it's not base 2, it's base 10, right? So yeah, it's gonna be base 10, right? This should be base 10, and time and then space is gonna be space complexity is gonna be O of n, right? Because we are adding at most all of the numbers. So space is this one and the time is this one. It's not O of n, right? So let's see if it works on that. So let's see it. So as you can see, passed for the first test cases, and let's see if it works for all of the test cases given. So as you can see, passed, and thank you very much.